You're backpacking. Okay. All right. So here we go. This is really important. So I want, even if you're finishing your survey or you're doing something else, let me see your little eyeballs for a minute. Okay. This is one of those sections that is kind of weird. And students go into this thinking, I know how to do this. I know how to do this. And you totally know how to do the beginning of this, but then it's going to get wonky quick. Okay. And so I want everybody to realize that there's a whole nother part to this that's super strange. Okay. Where you're going to have to test intervals. You're going to have to figure out if points work. It's kind of a strange situation. So you may want to look up here a little more than ordinary. How does that sound? Okay. Okay. So here we go. Let's just talk about it. Page 27. So we are going to have inequalities. So polynomials, meaning just one little line of stuff like this guy. And then towards the back, we're going to have rational inequalities. Remember, that's when you have a polynomial over a polynomial. So you have like a fractional situation. We'll do that towards the back. But the key here is that you have inequalities. You do not have an equal sign. So, all right, I'm trying to stupid focus. There we go. Okay. So since you don't have an equal sign, that's why we have to test points. So here are your steps. So we're going to move all the terms to one side and solve it like it's an equation. Okay. These solutions that you find, those are not your answers. I'm using solutions with air quotes. Maybe I should put quotes in there. Okay. Those are boundary points. You're going to draw a number line and make those boundary points. They are not your answers. That's way up on step 2. They can't be your answers if you're only halfway through the steps, right? These make intervals on the number line. Then you're going to have to test each interval to see if it works, if it's true, okay? And then based on that, your answers are going to be intervals in interval notation. Your answers are not going to be one little number. Your answers are going to be intervals using either parentheses or hard brackets, okay? So your answer could also be no solution. It could also be all real numbers. Look at that. It's just the wild, wild west out here. Okay, so here we go. Let's try this little guy first. So first thing we're going to do is we're going to move everybody to one side. So I'm going to subtract 8 over to the other side. So what I'm going to get is x cubed plus 2x squared minus 4x minus 8, which gives me a 0 on the right. That's pretty easy, right? I'm just moving everybody over. Now, I know that he is an inequality sign, but we're just going to kind of pretend like he might be a 0, and we're going to, an equal sign, and we're going to solve this. So let's see if we remember how to solve things. No GCF, 4 terms. How do we solve a 4 term? We group them, right? Remember the grouping? Okay, here we go. We're going to group. So now I'm going to look for a GCF in this first little bunch, which is x squared. And I'm going to come up with x plus 2 in parentheses. Then I'm going to look for a GCF in this next little bunch, a -4. Good. Watch your signs. When you divide out a -4, you get x plus 2. That's your little checkpoint, right? Both of these are the same now, so we're good. I'm going to pull one of them out, and then I'm going to write what's left. Yep, and I already heard it's a difference of squares. And remember, what you're keeping in your mind is how many answers should you have? 3. This is only going to provide you with 2, but this is still a difference of squares. So we can still keep factoring this little guy. Okay, so I'm just going to bring this guy on down. Okay. This one, I can factor into 2 parentheses because he's a difference of squares. I have a plus and a minus. Square root of x squared, square root of 4, and there we go. Okay, we did it. We have all 3 packets. We thought we should, and now we do. Is everybody good with that part? That's pretty standard. I feel like you guys are good at that. Okay. All right, now we're going to solve each one. If I set x plus 2 equal to 0, I'm going to get x equals -2. Now this is going to give me the same thing. This is going to give me x is +2. Okay, so what we have done now is we have gotten to step 2 because these are not our answers. These are boundary points. That's why you have this whole page to do one problem. Okay, so now what we're going to do is we're going to draw a number line. Okay. And then I'm going to put these points that we came up with here on the number line. Well, I have a -2, put them somewhere. Now, it just so happens I have 2 of those. You don't have to repeat it. Okay, I have a +2. There we go. So what I'm going to do now is I'm just going to kind of make these boundaries. What these boundary points have done is they've taken your all real number line and they've divided it. And so in this case, we actually have 3 different intervals. Does everybody see that on our number line? So I have this interval, I have this one, and I have this one. So the answer to this problem is either going to be this interval, this interval, this interval, maybe 2 of those intervals, maybe all 3 of the intervals, maybe none of the intervals. Okay, so, but we have our intervals. Okay, let's figure out what the heck are these things. All right, well here, first of all, this interval goes from -infinity, which is a parenthesis, to -2. Now, how are we going to know what kind of enclosure we put with -2? That comes from your original problem. So if you look back at the original problem, this is simply a greater than sign. So is that parenthesis or hard bracket? Parenthesis. That means every single enclosure is going to be parenthesis. If this had a line under it, that would mean anytime you're dealing with the boundary points, they got a hard bracket. Okay, and we'll do some of those too as an example. The infinities have to have a parenthesis. Okay, so since this was a parenthesis situation, that's what this one gets. Okay, this interval is going to be -2 to 2. And this interval would be 2 to infinity. Okay, just so we're kind of aware what those intervals are. All right, say that again. Oh, if we need more than one, they absolutely get a union, right? Absolutely, and we'll do some of those too. Okay, now what we're going to have to do is test each interval. We want to test a point in each interval. This is where everybody in the room could have a different point if they wanted, okay? So you know me, I'm always a little extra. I like to kind of make a chart. You don't have to make a chart if you feel like it's too much work. But since I have 3 intervals, I'm going to make a little chart that says interval, test point, and then I'm going to evaluate it into my poly, and then I'm going to come up with a conclusion. Now, you certainly don't have to do this if you feel like Ms. Holcomb has lost her mind and she's just getting a little too excited about math, okay? If you don't want to do this, you can simply pick a point from each one and plug it in if you feel like this is a little much for you to do this part, okay? But what I'm going to do is just take each interval and I'm going to conduct a test on it, okay? All right, now I need a point for this first interval. It can be any number from -infinity to -2, any number at all. It just so happens that I chose -3. Now, the only thing you can't choose is the boundary point. So you can't choose -2, and of course you can't choose -infinity, but you can choose any other point. So Samia may choose -4. Alexis may choose -5. I'm going to choose -3. It doesn't matter what you choose as long as it's inside the interval. Does that make sense? Okay, so I chose -3. Now I'm going to evaluate it. That means I'm going to go back up and take this original poly that we had, and I'm going to put in a -3 for my x's. That's what that means. Okay, so I'm going to write the poly over down here just so I don't have to keep going back up there. Okay, that was my original problem, was right here. So what I'm gonna do is I'm gonna take my test point and plug it in for x. So I'm gonna have -3 cubed plus 2 times -3 squared minus 4 times -3. That's supposed to be greater than 8. Okay, that's the plan. Everybody see kind of what I did there? Okay, so now I'm just going to work it out. So this is going to be -27 plus 18 plus 12. Okay, so this ends up coming out to be -5 greater than 8. That's what this comes out to be. This whole left side ends up being -5. Is -5 greater than 8? No. So that means this interval is not an answer because it's not true. No matter what you chose to put in here, you would have gotten a statement that's not true. If you chose -4, -5, whatever you chose. Does that make sense? Kind of? You're just testing to see, do numbers in this interval make this original problem true? Okay, let's try another one. Okay, next interval. Now we need a number. We can't use -2 and we can't use +2, but we need something between -2 and +2 to test. You could absolutely do 1. I'm lazy, I already did 0 because I love a 0, okay? But you can absolutely do 1 and you'll find the same conclusion, right? So you can absolutely do 1. Okay, so if I'm just gonna throw this in here. Oh, sorry, just, okay. So that the whole left side is going to end up being 0, right? Is that, I don't think that ends up being -5 up here, but I don't even know. But he's not greater than 8. I just looked at, what is it? I'm sorry. 3, thank you. Okay. 3 is not greater than 8, so it's still no. Okay. We come down here. This whole left side goes to 0. Is 0 greater than 8? Nope. It's not going to be this interval either. Okay. This is when students get all impatient and they say, oh, well, then it's this interval. I'm not testing that last one. I'm just going to say this is the answer. It's got to be that. Well, guess what? Sometimes it's not any of the intervals. So you have to test the last interval, because if this one is also a no, that means the answer to the whole problem is no solution. So you have to keep testing. Okay, let's go to the next one. All right, next interval, we need something between 2 and infinity. How about 3? That's what I did. Okay. But I've already showed you I don't have the answer anyway. So, okay, so I'm going to plug in a +3. And I'm going to see if that comes out greater than 8. Okay, it does, but I don't know what it comes out to be. 27 plus 18. You got 15? I got like 33, but that doesn't mean that's right. Okay. Either way, whatever it is, we know it's greater than 8. 33 or 15. We don't know. Okay, how's that? Either way, he's greater than 8. That one's correct. So our answer is this interval. That's going to be our answer. So, okay, that's it. Okay, well, we're going to graph it on a number line. Okay, so, all right, because 33 was greater than 8, that means our answer to this problem is the interval 2 to infinity. That's our answer. Then it wants us to graph it on a number line, so we don't have to use that junked up number line. All we're going to graph is a 2. And then to go from 2 to infinity with a parenthesis, that's our answer right there. Okay. Both of those together are your answer. Okay, so you didn't have to make this big drawn out chart. You could have just done this part and picked a number in each one and plugged it into the inequality and kind of worked it out in your calculator. But I just like to make a little chart. Okay. All right, does that kind of see what we did there? Let's do some more because I know it's strange. Okay, is everybody okay if I flip it over? All right. Okay, I promise not to take up so much room on this one. He's tiny. Okay, here we go. So we have our little inequality right here. So if it's an inequality, we're going to have to do this testing points, this interval situation. That's how you solve these inequalities. All right, so here we go. First thing we're going to do is move everybody to one side. So I'm going to subtract the 6 and I'm going to add the 3x squared. And when I kind of clean him up and put him in a nice order, that's what I get. Okay, everybody okay with that? All right, now just I kind of notice right away my inequality sign is less than or equal to. So when it comes down to making my intervals, am I going to have parentheses or hard brackets? I'm going to have hard brackets. So just kind of make that little note somewhere, even if it's in your little mind. Okay, now we need to solve this. Well, there's no GCF. He's 3 terms. He's not a monic. And he's not a PST because this is not a perfect square. He's one of those little stinky ones we have to do some extra work on, right? So here we go. We're going to do 3 times -6. One of those, -18. That means somebody's going to be positive, somebody's going to be negative. We want to add those 2 factors together to give us +7. You guys are asleep. How about 9 and -2? We could add those and get a 7. We can multiply them and get a -18. Okay, I'm going to throw little x's in the back and I'm going to replace the +7, right? And turn it into a 4 term so I can group it. Okay, so I'm going to have 3x squared plus 9x minus 2x minus 6. Okay, and if you don't like to do it this way, remember you can factor it any way you want as long as you get the same answer. All right, here we go. I'm going to group him. I see a GCF for the first group of 3x. I divide 3x from both terms and I get x plus 3. Okay, I go to my next little packet, see a GCF of -2. Divide each term, watch your signs, x plus 3. Okay. And then just kind of clean them up there. And there we go. Okay. Now I noticed that there was an exponent of 2 on our original problem. So we should have 2 answers, 2 packets. Sure enough, I do. So we're good to go. These are going to give us our boundary points. Okay. So as far as boundary points go, I'm going to go ahead and just say this one. I'm trying to save room, which is why I'm throwing it over here. If I solve this one, set it equal to 0 and solve it, I get x equals -3. Okay, this one's a little tougher to do that in your head. So set it equal to 0 and solve it. I'm just trying to save room. If I add the 2 to the other side, that becomes positive. Divide both sides by 3, I get 2/3. Sometimes your boundary points are really stinky. Like that one, that's kind of weird, 2/3. That's okay, because we're not using it. It's just the boundary, okay? All right, is everybody okay on getting those? All right, so now remember, that's when you're gonna draw the big number line. You're gonna put in your boundary points and kind of create these intervals, right? So 2 points are gonna create 3 intervals, right? 3 points would create 4 intervals, and so on. So in this case, I have 3 intervals to look at. Okay, this first interval, I go ahead and like to just write my interval so I don't get confused, is going to be -infinity to -3. But what kind of enclosure is -3 going to get? That hard bracket, right? Remember, that's just from your original problem. That's because this had the line under it. That's why. Okay, now I'm going to do the next interval. These don't have infinities, so they both get hard brackets. Okay. And then my last little boundary is going to be 2/3 to positive infinity. Remember, infinities get parentheses. So there we go. Okay. All right. So now in this case, if you wanted, if you don't mind making a little chart, you can go ahead and make your little chart, right? We're going to have an interval. We're going to have a test point. You don't have to draw it if you don't want to. You can do it in your head. Okay. Now we're going to evaluate. And then that's the one you leave the most room for. And then you're going to make a conclusion. Yes, no, that way. Okay. So I'm going to put in my intervals. Okay. Just put in my intervals. All right. Here we go. I'm going to get my original problem back up here. Okay. So now we need test points. Okay, so let's see what I did. I didn't write down the answers anyway, so we can pick any little point your heart desires. Okay, something between negative infinity and -3, but it can't be -3. I'll take it. Okay, here we go. So I'm going to evaluate it. I'm going to have 7 times -4. Then I'm going to have 6 minus 3 times -4 squared. Okay, this conclusion, this is going to mean -28 should be less than or equal to -42. Sorry, that's really tiny. Is -28 less than or equal to -42? No, yeah. So that means no, it can't be that interval. That kind of makes sense how we did that. You could have chose -5, you could have chose -6, whatever you want. Okay, let's look at our next interval. Our next interval is -3 to 2/3. You can't use either one of those. Which one does Ms. Holcomb love to use? How about a 0? If you've got an interval that has a sign change, negative to a positive, use 0. It's so much easier. Okay, so if I throw in a 0, I'm going to have 0 less than or equal to 6 when I evaluate it. Is 0 less than or equal to 6? Sure it is. That interval works. Okay, do we need to bother with the second one or third one? Should we just say, oh, forget it? Yes, you have to, because it could be that interval also works. Okay, so we have to keep going. Okay, something between 2/3 and infinity. How about a 1? That would work, right? Or 2, or whatever you like. Okay, so if I throw in a 1, that's going to say 7 is less than or equal to 3. Is 7 less than or equal to 3? No. Okay, so my answer for the whole problem then is going to be this one little interval, okay? And then I have to graph it on a number line with heart brackets. And there we go. And that's our answer. Okay. Does that sound good? Okay. All right. Let's just talk about the next one. We're going to skip him and go on to one that's a little different, but let's just talk about this next guy. So the next guy down here, he's got everybody on one side already, which is fantastic. You can go ahead and solve him. He ends up being a PST, but if you don't catch it and you just solve him, you get this. So you only have one boundary point, x equals 4. Well, if you only have one boundary point, then you only have 2 intervals. That's kind of nice, right? So I have this interval and this interval. Am I going to have a hard bracket or parenthesis around 4? Parenthesis. So you're going to be testing these 2 intervals. All right, let me go ahead and tell you what happens. When you pick something out of here to test, this interval is a no. You pick a number out of this guy to test, this interval is a no. What are you going to write? No solution. Or remember, you can do this. That means no solution. Okay. So, oh, yeah. We're just skipping him. Sorry. Yeah. I just wanted to skip him and go to another one that has a few more interesting things happening. Yeah. Is that good with everybody? Okay. And then, of course, if all three intervals worked, what would you write? All real numbers. If all three worked, and then you would do negative infinity to positive infinity. Okay. If all three worked. All right. Let's do this next guy. Okay, he's kind of interesting. That gets us closer to the rational one. Okay, this is our last polynomial one, except this little dude down here. Okay. All right, so we're all, oh yeah. You don't have that page? Oh, anybody else missing it? I wonder if your backpack ate it, honey. It might have. You know, it happens. If not, maybe just write it on a piece of notebook paper somewhere. I don't know. That's weird.
Yeah, no, it never came with it.
I'm sorry. See, it happens. Yeah, but her backpack eats everything. That's why I said that. Okay, do you have a piece of notebook paper you can put it on, Shalondra? Okay, yeah, because I want you to do this one because this one's going to be. I think this one's similar to the test. I can't be sure, but I know that you have a lot of these on your My Math Lab. Okay, so we're all on one side. So we're ready to go ahead and start factoring him because we need our boundary points. So I noticed that he does not have a GCF, right? And he's not a PST because this is not a perfect square, but he's a monic, which is so fantastic because I'm tired. Okay. All right. So we want factors of positive 35. So they either have to both be positive or both be negative. And we want them to add to give you negative 12. Perfect. -7, -5, or -5, -7. You can write them in any order you want. Because the important thing is that you get the boundary points. So our boundary points are going to be x equals 7 and x equals 5. Okay. All right. Well, here we go. We have this. We're going to put on, let's see, 5 here, a 7 here. Okay. And we get 3 nice little boundaries. Okay. Or 2 boundaries, I'm sorry, 3 intervals. Okay, let's draw our intervals. So this interval is going to be from -infinity to 5. All right, what kind of enclosure is 5 going to get? Good. Then we're going to go from 5 to 7. Gee, I wonder what our test point choice will be for him, huh? Okay, then we're going to go from 7 to infinity. So those are our 3 intervals we're going to test. Okay, again, if you want to do the chart, you can. Some of you have already figured out you really don't need the chart. You can just kind of grab a point in your mind, right? And plug it in and see if it works. It's just that, and that's what I do when I don't have a class to teach, but when you're trying to teach someone to do something, a chart kind of keeps some people organized. So that's why I always talk about the chart, but you don't actually, you know, it's not really necessary. You can just throw it right in. Okay, so first interval we're going to test is -infinity to 5. So we need a test point, 0. Now, let me point something out to you. Students really, they're very good at this. It's not hard, but let me tell you where they mess up. It never fails. There's at least 3 or 4 students that they get to the test and they get perfect intervals. They get their little everything sorted out. And they pick test points that aren't in the intervals. It happens every single test. They'll go, -infinity to 5. I'm going to choose 7. And then they'll test it. And you're going to get the wrong conclusion because if your test point's not in the interval, you don't know if the interval's right. It happens all the time, especially with negative numbers. For example, and I meant to bring this up here. Okay. With this guy here, you have no idea how many students are going to tell me, I'm going to test -2. And they'll put it in, and then they'll say, oh, it worked. Well, of course it worked because it was in the middle interval. That was the answer. You picked a point that was not in your interval. So I know that sounds stupid, but I'm telling you, it's not even 1 or 2. It's usually like 3 or 4 students do that. So please, please, please make sure your test point is in the interval. Okay, so 0. I'm sure you guys already have the answer, but if I go up here and I plug in a 0, what I find out is 35 greater than 0? Yeah, so that interval works. Fantastic. Okay, so do I have to go on and do the other 2? Yes, you have to go on and do the other 2. Okay, next interval, 5 to 7. Okay, I'm sure everybody chose 6. I mean, I don't know anyone that would choose 5.5, but yeah, -3. Yeah, but make sure it's in the interval, right? Okay, so now I'm going to take 6 squared minus 12 times 6 plus 35. What'd you get, Alexis? Or Teresa? Did y'all do that one? No? Okay. I think you get -1. Okay, good. So is -1 greater than 0? No, that interval is not going to work. Okay, last interval. All right, 7 to infinity. What do we want to choose? Ignore the child in the front. Okay, how about 10? I was going to go with 8, but Shalandra's just throwing it out there. Okay, so if we do 10 squared minus 12 times 10 plus 35, let's see, we're going to have. Okay, yeah, good, thanks. Okay, and you get 15. 15 is definitely greater than 0. Oh, this is a new situation we haven't had before. Before, we've only had 1 interval that works. Now we have 2 intervals that work. Okay, fantastic. So first interval is this guy. Second interval is this guy. And then what do we do in math to say it's him and him? The union. Okay, now don't forget, you're going to need to draw him on a number line. Okay, so you're going to have to remember how we do that. All we're doing is just drawing both. So in this case, you're going to have a 5 with a parenthesis that points this way. Okay. And then in this case, you're going to have a 7 parenthesis that points this way. It just means both of these. It means this little guy and this little guy, right? You chose both of them. Okay, good deal. All right. So now let's look at what that means for a graph down here. This is not a test question, but it is a My Math Lab question. Okay. So, oh, you know what? Poor Shalandra's looking at me like, please don't make me know that. I have one. All right. So this is just a My Math Lab question. Okay, so here we go. In this case, all it wants you to do is use the graph. And this is so much easier. I know it looks like it's going to be harder, but it's so much easier. Okay, here we go. So we have this crazy Polly, okay? So we don't even have to solve him. We don't even have to get boundary points because guess what? The boundary points were the solutions, which are the zeros, which are x-intercepts. So on this graph, here's a boundary point. Here's a boundary point. Here's a boundary point. Look at that. It already did it for you. So you have a boundary point of, let's see, +2. This tells you this one's -2/5. And this one's going to be -3. It already gives you your boundary points. So you already have your nice little intervals there. Okay. Then all we have to do is look at our intervals to see. Okay, so the next thing we're going to do is move everybody to one side. I was trying to figure out how I ended up teaching this because it's been a little while. Okay, so I just moved everybody to one side. So what we know is if this is the whole graph, we want the whole graph to be greater than or equal to 0. Does that make sense? Now that we've moved it over. Okay, so if we go over here and you already have your intervals, this interval is going to be negative infinity to negative 3. This interval is negative 3 to negative 2/5. We have another interval of negative 2. Oh, I should have put hard brackets. I'm sorry, guys. How do I know it's hard brackets? Greater than or equal to 2 and 2 to infinity. So those are all your little intervals. I should have drawn a chart. Anyway, so now there's a couple different ways you could do this. You could stick with kind of the way we had learned it, which is you choose a point in this interval, plug it in to the original, the way it was up here, and see what you get. Plug something in this, plug it in up here, see what you get. Choose something for this, plug it in and see what you get. But kind of a quick and dirty way, and I'm just going to show you this to help you get through the My Math Lab, is see how I rearranged it like this? And what it's saying is the entire graph should be greater than or equal to 0 to prove this true. This means that when the graph is positive x values, then it's true. When the graph has positive x values, then it's true. So what do I mean by that? Well, this whole side needs to be greater than or equal to 0. Let's look at this interval here. This interval contains a graph down here. Are these positive x values for this little graph or negative? Negative. So this interval is not going to be a part of it. Then I go to my next interval. It's from negative 3 to negative 2/5. Your graph is positive up here. See that? It's above the x-axis. So this interval is going to be true. Then I go to the next interval. These contain parts of the graph that are negative. We don't want that one. Then I go to this part of the graph. It contains x values that are positive. So your answer is going to be this. Okay, so if you wanted to put that on a line, you're just going to put it exactly the way that you see it. And that's it. Okay, now we're going to do the back page, so don't pack up yet. What I mean by that's it, I have to be careful what I say. It's like guys with the dog. If I say anything about going outside, the dog goes nuts. Okay, so all right, so that's just kind of a little quick and dirty way. You can still test every single interval and plug it back into this original. But if you solve it for 0, then the whole thing has to be greater than 0. Then you're only interested in the parts of the graph that are greater than 0. That's it. Okay. All right, we have one last problem. We're going to sneak in. Okay, everybody okay with that? All right, last problem's on the back. The only thing different about this problem, here it is, it's probably hard for you to find, is that it's a rational expression. It has a numerator and a denominator. So what are we going to do for that? You're going to set both the top and the bottom equal to 0. You're going to use the boundary points from the top and the boundary points from the bottom. Okay. Then you're going to test those intervals that creates. That's what we're going to do. Now, this is going to be just like a test question, and we're going to review it on Thursday, but here we go. If I set the top equal to 0 and solve, okay, what I'm going to end up with is that x equals -2. If I take the bottom and I set it equal to 0 and solve, I get x equals 9. These are both my boundary points. But there's going to be a difference here when we create our intervals. All right, so I'm going to put in -2 and I'm going to put in 9. There we go. Okay, Now let's talk about our intervals. Here's the difference. Besides the fact that the top and the bottom create your boundary points, let's write what our intervals are. Okay, this is going to be negative infinity to -2. -2 came from the top. If it comes from the top, you use whatever the inequality says to use. So what kind of an enclosure does the inequality tell us to use? A hard bracket. Here's where it gets strange. Now we're going to go from -2 to 9. -2 came from the top, so we're going to use a hard bracket because that's what the inequality said to use. But the 9 came from the bottom. Think about what these enclosures mean. A hard bracket means it can equal that, which is fine. If this equals a 2, -2 in the top, -2 plus 2 gives you 0. You can have a 0 in the top. That's perfectly acceptable. What happens if we have x equals 9 in the bottom? We're undefined. Does everybody see that? If you had 9 as your x in the bottom, you would be undefined. Are you ever allowed to be undefined? No. So if it comes from the bottom, it's always, always, always a parenthesis, no matter what the inequality says. So a bottom is always a parenthesis. Write that down because you'll forget it. Bottom's always a parenthesis. Top is whatever the inequality says. Whatever the inequality says is the top. Parentheses are always in the bottom. I don't care what the inequality tells you because otherwise it would be undefined. So our next interval is going to be parenthesis 9 to infinity because again, 9 came from the bottom. So you have to be very careful about who comes from the top, who comes from the bottom. You're going to test them the same way. Hold on. You're going to test them the same way. In this case, it turns out to be just this little guy in the middle. That's it. And then that would be your answer. Okay. But just really be conscious of the fact that if it came from the bottom,